More weirdness about the quantum world is that you're actually setting the values. The observation sets it. So it's not determined until you measure it. It's in an indeterminate state. And people want to say, oh, it's just unknown. No, it's not unknown. It's indeterminate. Until you measure it, it does not have a defined value. It has what's called a superposition. It has all of the values with a certain probability of measuring them. But once you measure it, then the world kind of snaps into this known state. So very different, right? Not at all what we experience in daily life. And that really gave people pause. And so for the last 100 years, people have been trying to, number one, internalize what the quantum picture means. And number two, fit it together with, well, if the world works this way in a quantized computer-esque fashion at a small scale, how do we get that to match up with large-scale phenomena like gravity? Okay, so let's go through again quickly the 20th century. We got classical mechanics, that's great. Einstein comes along, says, no, wait, there's some things that are incomplete. Einstein actually starts off the quantum theory, even though he didn't like it later on. Quantum theoreticians show up. Through the 30s, they build out these two new fields. And then through the 50s, they do some more research. We get the atomic weapon. The 40s, we get the atomic bomb. In the 50s, we get the fusion bomb, the hydrogen bomb. That's pretty dangerous, and there's a lot of concern about that. Through the 70s, you get quantum field theory, where they build out the quantum theories to be more complete. And then quantum chromodynamics is successive versions of it. They're really refinements of the same thing. And then around the 70s stops. We have what people call the standard model. That they found the Higgs boson at CERN, right? That's one of this particle zoo. They have a set of particles that they think they've identified. The Higgs was one of them. I think Peter Higgs figured out a boson called the Higgs boson in like 71 or so. And you find it.
Is Higgs a person?
He's a person, yeah.
And what is a boson?
There are two types of particles. They arbitrarily divide them into two types. One's called fermions, one called bosons, and that has to do with how they interact.
Who got to name these?
I don't think Fermi named it after himself, although he was a top physicist. Fermi did discover the fermions and classify them first, and other people called them fermions. If you're good enough at physics, you get to name fundamental particles.
Even if you shouldn't. Anyway, so a boson.
Let's go into what these are because it's actually kind of interesting. So that quantum property of spin.
What does spin stand for? Is that an acronym?
No, it's...
or just things are spinning?
Unfortunately, nothing is spinning. They just gave these things names that corresponded to the classical equivalents. In the early days, they thought maybe something is spinning.
Spin is a verb or a noun?
You can think of these things as all just properties.
Okay, properties. So spin. Go file, edit, spin.
Yes, exactly. Like the file has properties. The spin can be up or down. At the quantum level, the world looks like a computer. Things have values, and the values are quantized. They're not continuous. It's like a form on a website where it's got certain values. You can set it to this or that or the other. Like a drop down, it can be one of these values.
Set your margins, set your paragraph.
But it's more like on or off. It's not continuous. You can't be, I want to change it by a little bit. Like
it's a toggle switch.
Yeah, toggle switch. Exactly.
Like all of my settings on the iPhone. Toggle on, toggle off.
Exactly. Right. So that's how the world works at a quantum level. A quote-unquote quantum particle is a collection of properties that uniquely identify the particle. There's X many properties. If you fill them all out, that describes the thing. And that's kind of it. They don't have names, don't have any sort of identity. You can't tell them apart. Two things that have the exact same quantum properties, essentially they are the same thing. So that's very weird and confusing. All you get are a list of properties, and to the extent that they differ, you get two different things. And if they're the same, they're literally the same thing. Does that make sense?
It does not make sense, but I'm thinking about it.
Yeah, it's pretty strange, right? Because again, this is not how our world works at scales that we're familiar with. But take it on faith.
Do you have an example?
So think of a quantum coin. It can be heads or tails. It's binary. No other values, can't stand that, and there's nothing else you can do with it. You flip it, you get heads. You flip it, you get tails. I could entangle it with another coin. So now you and I both have a coin. We take them together, we do the magic trick. They're now entangled. We take them apart. Now neither of us can look at it. If you look at yours and it's head, mine is tails. So even if we separate them physically, they're connected in some kind of weird geometric way.
Yes, I get that part. The toggle switch is what I was struggling with.
The toggle switch is like the up or down.
But would something have multiple toggle switches, and depending on which ones were toggled on or off, you would have different types of particles?
Exactly how it works.
So there's no gradient. It's like dot, dot, dot. That
Yep.
makes sense to me. Okay.
And so
Yeah.
when you do particle transitions and the stuff that they do in colliders and reactors, you're essentially flipping quantum properties. This thing goes from a this into a that.
Okay. So there's no developing into, like a flower grows and then a leaf comes out and it's still a flower. It's just gradually turning into a flower. None of that. No flower, flower.
It can break into multiple things. So you can have a thing like thing A that breaks into things B and C. And then there's conservation laws where if the mass of A is this and the mass of B is this and the mass of C is this, B plus C has to equal A. Right. It's abrupt transitions. Exactly. Yes.
Sounds like my life. I would say that checks out. It checks out. What is the name for the system that is defining my reality again?
Quantum.
Quantum.
Yeah.
Yep. Sounds right.
Okay. So it turns out AIs know quite a lot of very high-end physics, right?
Okay, cool.
So we got...
Okay, before you get into that, could I ask then an LLM about a mundane boy problem, but to have it work it out?
Express it in quantum mechanics?
Express it in quantum mechanics, not in just regular mechanics, but quantum mechanics?
You should try this.
Oh, let's try that right now.
I was going to say, you're going to try it right now, aren't you?
Yes, I am going to try it right now. 1 second. Am I kiboshing your story?
This makes it more fun.
I turn everything into like...
dating problem. Yeah.
Okay, so the situation is Laura has gone on a very good 2 dates with a boy, but yet has a roster. And all dating advice says it is much better to keep the roster going and not all eggs in one basket. However, this 2 date has blown the roster out of the water. Therefore, what is the best way to move forward? Caught between conventional dating advice and what would quantum mechanics tell me to do?
See what we get.
So I'm in a state of superposition. Okay, so how do you get to hear this? Simultaneously invested in the 2 date connection and still maintaining the roster.
You are in a state of emotional superposition, simultaneously invested in the 2 date connection and still maintaining the roster. This duality mirrors the idea that all possibilities exist until observed or acted upon. 2. Uncertainty principle. The more you focus on defining the nature of your connection with the 2 date partner, the less certainty you have about the outcomes of keeping or ending the roster. The 2 date connection feels significant, but you're tethered to external advice that values hedging your bets over wholehearted pursuit. The roster strategy, while rational, assumes relationships are transactional and predictable, much like classical physics. However, quantum mechanics reveals that relationships, like particles, respond uniquely to observation and intention. When you observe or focus on one path, the wave function collapses and a single reality emerges. This means continuing the roster dilutes your focus and may introduce unnecessary noise into a clear signal. Choosing the 2 date connection does not guarantee success, but allows you to observe it fully, bringing its potential into sharper reality. How to move forward. 1. Trust the observation. If the 2 date connection feels authentic and meaningful, give it the attention it deserves. 2. Release fear of scarcity. Abundance comes from aligning with what feels right, not from juggling options out of fear. 3. Keep a light touch. Just as quantum systems thrive in states of balance, avoid rushing into intensity. Explore the 2 date connection without overcommitting or defining it prematurely. By aligning with your truth and investing in what feels deeply authentic, you create the conditions for meaningful connection.
Oh, that's great.
Isn't that sweet? That's awesome. Emotional superposition.
A lot of these ideas are very useful. People are like, why do you study quantum mechanics? I'm like, you'd be surprised.
How that really ups your game. It says physicists don't have game.
People who have observed them.
I know, your wife is like hot, blonde, smart, kind, funny. Like, I would say that quantum mechanics has worked out for you.
True.
David can pull, everyone. He can pull. So, what have we learned?
We've learned that quantum mechanics analogies seem to work surprisingly well for dating.
Yeah, I think so. It checks out. And I think that's why I pulled out the dating thing, because I was like, oh, I have 2 different sets of laws operating simultaneously, and they're grading on each other. Because I could not take 2 date man and integrate him into the roster. It didn't make any sense to my brain. So the roster is like regular mechanics, and then 2 date man is like quantum mechanics. and they have different principles.
Yeah.
So separating a two-date man, the roster makes sense to me. Like, the roster was working. You just can't take this indeterminate and add
Indeterminate.
He's the indeterminate. Yep.
And I like the idea that like once you observe that interaction, now you're a part of that interaction.
Yeah, exactly. I realized the interaction is indeterminate still. Like, if I look at it transactionally, it will all go to shit, basically. And I think that's what was driving me crazy yesterday, is that basically I was looking at it through a transactional and a non-transactional lens, and it looked like a horror show through a transactional lens, and then like I won the lottery through a non-transactional lens. But I was trying to figure out what it was, determine the indeterminate. I didn't think to notice that there are two different lenses you could let the light through with. I wasn't thinking about the lens, I was thinking about the thing that I was viewing. But it's really the lens that was fucking me up. Lens one, lens two, lens one, lens two.
And I like that idea from quantum systems that like the observer is part of the system. Seeing classical systems as an observer and you just be outside the system. You can't do that in quantum systems because you are interacting with the system to even make a measurement, and your measurement then changes the system.
Yeah, I'm the other half of the plus one. So like right. I'm the other half of the date. I am a determinant and I'm an observer simultaneously. I'm observing the situation and I'm determining the situation that I am observing.
Yes, exactly.
Oh, I get it.
Yeah.
Thanks for explaining physics, David. Quantum ones.